Oh, drat these computers. They're so naughty and so complex. I could pinch them.
What's up, everyone, and welcome. In this episode, we are going to talk about supply chain attacks. Whether you talk about the Solarwinds hack, or Codecov, or Ccleaner, or the Ukrainian accounting software MEDoc, supply chain attacks are on the rise. Supply chain attacks are scary because they are hard to deal with, and because they make it clear you're trusting every vendor whose code is on your machine, and you're trusting every vendor's vendor. Believe it or not, supply chain attacks are not new. They were demonstrated around 40 years ago when Ken Thompson, who was one of the creators of the Unix operating system, wanted to see if he could hide a backdoor in Unix's login function. Supply chain attacks have come a long way in the last 40 years, and we want to make sure we are secure and prepared in case one of these attackers tries to infiltrate our systems. So today, I'm going to take a look at this topic and see how we can protect ourselves, our systems, and our clients from it. The goal of this video is to help you understand what supply chain attack means, along with the various types of attack that exist. This way, you can have a reference to check your own systems and processes to see whether or not your current plan or the way you work has any vulnerabilities up to these types of attacks. It also helps you so that you can read about these attacks and be able to spot them by yourself. The agenda for today is going to start off with a definition, as always. What is a supply chain attack? In order to build a great defense, we must intimately know our enemy. We're then going to move on to the anatomy, or the types of attack and how they work. If we know the pieces and how they work, we can evaluate where we are vulnerable. And we're going to finish up with steps to improve. What can I do? Now, before we get into it, here is just a list of some of the resources I used to create this episode. As I always say, you can do the research on your own, or you can sit back, kick your feet up, relax, enjoy the benefit from my work. What is a supply chain attack? A supply chain attack is a cyber attack, that seeks to damage an organization by targeting less secure elements in the supply chain. A supply chain attack can occur in any industry, from the financial sector to the oil industry to a government sector. Cybercriminals typically tamper with the manufacturing process of a product by installing a rootkit or hardware-based spying components. The umbrella term supply chain attack covers any instance where an attacker interferes with or hijacks the software manufacturing process or the software development lifecycle, such that multiple consumers of the finished product or service are impacted detrimentally. This can happen when code libraries or individual components being used in the software build are tainted, when software update binaries are trojanized, codesigning certificates are stolen, or even when a server hosting software as a service is compromised. With any software supply chain attack, attackers interject themselves either upstream or midstream to cast their malicious activities and their after effects downstream to many users. Subsequently, compared to an isolated security breach, successful supply chain attacks are of a much larger scale with far-reaching impact. So let's take a look at an example. I want to use this older example, yes, from 2017, but it clearly shows the different elements that can and often are used to execute a supply chain attack. So let's think about browsers and the extensions in browsers. They're developed by somebody, and browser extensions are a powerful means of adding functionality to the Chrome browser, or Internet Explorer, or Firefox, etc. And it gives you features ranging from easier posting to content, social media, or to integrated developer tools to help you do your job. At the end of July and the beginning of August in 2017, several Chrome extensions were compromised after their authors' Google account credentials were stolen via a phishing scheme. Now, if you haven't watched my episode on phishing, there will be a link above here. Let's get my finger back in the screen so that you can watch that. It's an extremely important topic for anybody working in any company, that they don't succumb to this. So, the phishing scheme resulted in hijacking, or the phishing scheme and the stealing of the Google account credentials resulted in hijacking of traffic and exposing users to potentially malicious pop-ups and credential theft. Specifically, extensions included Web Developer version 0.4.9, Chromatana version 1.1.3, Infinity, New Tab, Copyfish, WebPaint, Social Fixer, and a number of others. Supply chain attacks may involve different types of cyber threats. the flow I'm going to show uses the security incident of the compromised Chrome extensions that from 2017 I just described as a use case and presents the steps involved in the attack. This supply chain attack involves phishing, identity theft, web application attacks, and web-based attacks. So we have our attacker, as we've seen in many of my episodes in the past. The attacker sends a malicious email to the developers of Chrome extensions. So he looks on the extensions and he tries, he finds either their GitHub account and then scrapes their GitHub profile and finds an email address of the actual developer, sends them an email as if it's coming from Google Dev Support, as you can see here. So he opens the email, and inside the email there's this really important message that says your Google Chrome item with the name and with ID, and the ID did not comply with our program policies and will be removed from the Google Chrome Web Store unless you fix the issue. So it's an extremely important sounding message to kind of throw you off guard. They have a link in there, and that link uses the bit.ly link shortening tool to do a number of things. One of them is to obfuscate or to hide the final destination. Who knows what the domain could be? It could be imascam.com, but you won't see it because you see a bit.ly link here. So you click through, and it looks like an official Google page. So you're not focusing on the URL that's in the browser. You're focusing on the content. Hey, it's got Google's logo, it's got the login, exactly where you know it being from the developer Google developer web page. So you enter in your information. Erroneously, it's a mistake because you're entering your information in a fake Google account. Now the attacker has your credentials, so the phishing attack worked. He now has your login credentials to the Google Chrome developer portal. So what does that mean? Well, that now means that he actually can make changes to your code. He can have access to your code, make changes to your code, and update new versions to the Google Chrome extension store. What he puts in the code is actually a call to an external script that he owns, which will then do malicious things on any person who's using your extension in their browser. So just to kind of break down this and get to the important stuff, he creates a variable called hash, which actually creates the domain where he wants to pull this script from. Then he creates a variable config fragment, which is just stringing together the code to make a script block so that he can, as the source, call his newly created domain up here and pull in the ga.js script. Now that script has all this malicious code that I'm going to describe in a minute and tell you what it does. But he then, with this script block created as a variable config fragment, he appends it to the page. So append child range create contextual fragment config fragment. So this is being added to every page that you visit via the browser, which means all of the session cookies for whatever website you might be visiting, whether it's Facebook and you're logged in, or whether it's Google or LinkedIn or anywhere that you're going, AWS or your hosting provider, if you're already logged in, they have access now to those credentials. So you're either an existing user who is now updating the plugin, or you are a new user who finds this great plugin that's going to help you. When you install it, you now have a legitimate piece of software that has been Trojanized via this what started as a phishing attack. So now that the attacker has you with their extension installed, with their malicious code, they can now use that JS script to malvertise, essentially take over the page. The attacker manipulates the traffic and malvertises via the extension that's installed on the users. So it's because the extension actually gives the attacker access to sort of control the browser. Through that extension, they now have access to control everything that you see to a degree. They could, you type in Google, they could send you to a fake Google page where you just, they're tracking everything that you do. If you try to go to chase.com, they could take that and bring you to a fake Chase. They can basically control everything in the browser. They own your web browser. So The final thing that it does, or it has the capability to do, is steal your Cloudflare account credentials. As I said, it's in the browser, it controls the browser, any page that you're on, it has access to. So if any of these extension users had a Cloudflare account, and either logged in or were logged in and visit that site, this extension now has access to those details and can steal those credentials. So, identifying the cyber threats involved in the supply chain attack provides reference points for us to improve our security. So we'll start off with the phishing. End users should use two-factor authentication whenever possible. Companies should raise awareness regarding elaborate phishing campaigns through proper training. We then move on to identity theft. It happened twice here. The identity theft happened to the developer in terms of getting his Google Chrome developer credentials, as well as the end user of the extension in terms of getting their Cloudflare account credentials. So when it comes to identity theft, users should use long, complex, and unique and secure passwords, as well as two-factor authentication whenever possible. We next move on to web app attacks. So disable software or extensions that you're not really using. We all find these extensions and we think that they're great and they're going to help us out, and then we end up honestly not using them. So make sure you disable them and ultimately remove them from your browser. Then we have the web-based attack. You have to keep, and this would be on the end user because they're being malvertised and etc., etc. You have to keep your operating system and your installed software updated as soon as new updates are available. Now up next, we're going to take a look at the 6 main types of supply chain attacks and see what differentiates them from each other.
Let me take a minute to give you some powerful reasons why you should share this video. Now, if you have seen this before, feel free to skip to the next section or just enjoy it again. If you haven't seen it yet, I want to show you how you can be a superstar in your team and your company just by sharing this video. First off, I really appreciate you watching this episode, liking it, and of course, subscribing to my channel. But I ask you to share it through any and all channels you have access to, whether Facebook, Twitter, LinkedIn, YouTube, Pinterest. You can link to it from your websites or even send it in an email to your colleagues, friends, and family. If we can spread this information to enough people, we all together can work to make the internet more secure. So, share it with developers in your team or developers that you know so they can integrate the security measures I will outline in this episode directly into their workflow. Share it with quality testers in your team or ones you know so they can benefit from this information and improve things like writing their acceptance criteria and test cases. Share it with project managers and product owners so they can make sure projects have the right security principles in mind and can talk intelligently to stakeholders about the importance of these measures. Share it with CEOs, VPs, and managers to show them that you're on top of these topics, taking them seriously, making you look like a superstar in their eyes. And finally, share it with your mom, dad, grandma, or friends, or anyone you can think of. Keeping them safe and helping them have a safer experience on the internet will definitely save you time and headache. Now, if you haven't already, right now is the perfect time to pause this video and share it before we really get deep into the content. Thanks again for your support.
So as I mentioned, there are generally 6 types of supply chain attacks that are discussed. There is an upstream server compromise, there is a midstream compromise to ship malicious updates, there's a dependency confusion attack, there are stolen SSL and code signing certificate attacks, there's targeting developers, CI and CD infrastructure attacks, and there's using social engineering to drop malicious code. We're going to start off with the upstream server compromise. With most software supply chain attacks, an attacker breaches an upstream server or code repository and injects malicious payload, like malicious lines of code or Trojanized updates. That payload is then distributed downstream to many users. From a technical standpoint, however, this isn't always the case. The Codecov supply chain attack is one such example. Now, if you haven't watched my episode on Codecov, here is a link above for you to check it out. Although the incident has drawn comparisons to the Solarwinds breach, there are stark differences between the two attacks. The Solarwinds supply chain breach was the work of sophisticated threat actors who altered a legitimate update binary. As previously analyzed by FireEye, the malicious code contained in the refresh internal method of the counterfeit DLL is shown here. That went too fast. The malicious code is here. This method invokes the HTTP-based backdoor when Orion loads the inventory manager plugin. The SolarWinds upstream attack, however, only took full force when the altered binary made its way downstream to over 18,000 SolarWinds Orion customers, including U.S. government agencies. So it had to travel from upstream down to a downstream user before it was able to take effect and be used. On the other hand, in Codecov's case, no malicious code was distributed downstream. So yes, the tool was changed, but the tool was not a product that would go downstream to a user. It actually stayed stationary. So there was no distribution required. You didn't have to run an update in order to get the new version, which would have this DLL as an example. The after effects of the Codecov attack were distributed downstream. So Codecov attackers had obtained credentials from a flawed Docker image creation process that could be used to modify the Codecov bash uploader. As per the official security advisory, the attacks then modified the Codecov bash uploader, hosted on the Codecov server itself, to collect environment variables being uploaded from customers' continuous integration delivery and continuous delivery environments. So the Codecov bash uploader is a stationary tool that lives on the Codecov company's server. It's an endpoint. And what all of these customers were doing, they were sending data to the Codecov bash uploader to then be stored in their accounts, and like they can do charts and see, like how successful their CI/CD is, and what problems arise, etc., etc. So their repositories, or their deployment process, or their continuous integration process, was always sending information, or was trying to send information, and the way it gets the information into Codecov's tools is through this bash uploader. Although Codecov bash uploader script lived and continues to live on the Codecov server itself at codecov.io/bash, thousands of repositories, as I just said, were pointing to the link already to send information upstream from their CI/CD environments to this bash uploaders. As such, the malicious code remained present only at the compromised upstream server without any downstream distribution of the code occurring, because the so-called downstream repositories were already pointing to the Codecov server that hosted the bash uploader script. Yet, these downstream repositories were affected by this attack as they were configured to upload their data to the Codecov's bash uploader, which I just mentioned. In fact, Codecov attackers reportedly breached hundreds of customer networks using credentials collected from the hacked bash uploader. Not long afterwards, HashiCorp disclosed that the Codecov incident led to the exposure of its GPG private key used to sign and verify software packages. Twilio has also disclosed some impact from the attack, and other companies are stepping forward with similar disclosures. So they're all sending information and sending sending tokens and information that have to deal with their CI/CD. So if they have to send their, for example, GPG private key, that would be passed to the bash uploader tool. And since the bash uploader tool is now hacked and basically leaking, everything that comes in is being leaked through to the hackers now have all this information, including all of this sensitive information. And that's what they then use to hack into hundreds of companies. So a piece of software was not installed locally on somebody's machine, as in the previous case of SolarWinds, where SolarWinds software that they deliver to you was attacked, and then through that delivered Trojan or that delivered malware, your systems get infected. With Codecov, it was they have a tool that they provide, and you're constantly sending information. And this tool itself was hacked, and a sort of a stream of anything that comes through was passed through to the hackers, so that this was not installed on your local system. This is something that you trust is secure, and you're passing your information to based on that trust. So that's upstream. Midstream. The term midstream is being loosely applied here to refer to instances of attackers compromising an intermediary software upgrade, functionality, or a CI/CD tool rather than the original upstream source code base. Recently, Click Studios makers of the password state enterprise password manager used by many Fortune 500 companies, notified customers of a supply chain attack. Attackers compromised password state's in-place upgrade functionality to distribute malicious updates to password state users. The illicit update contained a modified DLL file titled moserware.secretsplitter.dll, a small part of which is shown here. It's a little fuzzy. In a security advisory, ClickStudio stated the compromise existed for approximately 28 hours before it was closed down. Only customers that performed in-place upgrades between the times stated above are believed to be affected. Manual upgrades of password state are not compromised. Affected customers' password records may have been harvested. Unsurprisingly, phishing attacks against ClickStudio's users soon followed, with attackers putting illicit links to an updated malware version in these emails. So here you can see similarities between what happened with the Kaseya hack last week, where right after the Kaseya attack, a cyber gang decided to perform a phishing scam, taking advantage of the fears of all the people who think they have Kaseya or something to do with Kaseya to get them to download some malware. Well, in this case, with ClickStudios, the same thing happened. So in addition to having a technical aspect to it, like, for example, the upgrade process being tampered with, this supply chain attack had a social engineering aspect as well. In the counterfeit update.zip file, which is over 300 megabytes in size, it was discovered the attackers had managed to alter the user manuals, the help files, and PowerShell build scripts to point to their malicious content distribution network server. The social engineering aspect to this attack also demonstrates another weakness, that humans, especially newer developers or software consumers, may not always suspect links to content distribution networks, whether these are suspicious or not. This is because CDNs are legitimately used by software applications and websites to deliver updates, scripts, and other content. Unlike credit card skimming attacks such as MAGAcart. Now, if you haven't already watched my episode on MAGAcart, there's a link right above here to that episode. So MAGAcart are yet another example of this kind of supply chain attack. In some attacks, Amazon CloudFront CDN buckets have been compromised to distribute the malicious JavaScript code to a wider number of websites that rely on such CDN. Next, we have dependency confusion attacks. In 2021, no piece on supply chain attacks can be complete without mentioning dependency confusion, especially because of the simplistic and automated nature of this attack. Dependency confusion attacks work with minimal effort on the attacker's end and in an automated fashion due to inherent design weaknesses found in multiple open source ecosystems. Put simply, dependency confusion or namespace confusion works if your software build uses a private, internally created dependency that does not exist on a public open source repository. An attacker is able to register a dependency by the same name on a public repository with a higher version number. Then, very likely, the attacker's public dependency with the higher version number will be pulled into your software build as opposed to your internal dependency. So let's say you develop a framework or a dependency inside of your corporation and it's not public. You don't want anybody to know about the code or know about it. So you don't create a public repository for it. But somebody else sees this private dependency and they go and create a public repository, give it a higher version number, and essentially the code inside of there is malicious. That's what that breaks down to. By exploiting the simple weakness across commonly used ecosystems, including PyPy, NPM, and RubyGems, ethical hacker Alex Beerson was able to hack into 35 big tech firms and walk away with over 130,000 in bug bounty rewards. Days following Beerson's research disclosed thousands of dependency confusion and copycat packages began flooding Pi, NPM, and other ecosystems. Although most of these copycats were created by other aspiring bug bounty hunters, some went a step too far by targeting known companies in a malicious manner. There are multiple ways to resolve dependency confusion, including reserving the names of all your private dependencies on public repositories before an attacker does, and using automated solutions such as Software Development Lifecycle Firewall that prevents conflicting dependency names from entering your supply chain. Owners of open source repositories can adopt a more stringent verification process and enforce namespacing and scoping in place. For example, to post packages under the CSO namespace or scope, an open source repository could verify if the developer uploading a package has rights to do so under the name CSO. Java Component Registry repository Maven Central employs a simple domain-based verification to verify namespace ownership, a practice that can easily be modeled by other ecosystems. Similarly, packages published to the Go package repository are named after the URL to their GitHub repo, making dependency confusion attacks much more challenging, if not outright impossible. Next, we have stolen SSL and codesigning certificates. With an increase in HTTPS websites with SSL and TLS, certificates are now ubiquitously present and protect your online communications. A compromise of an SSL certificate's private key could therefore threaten the secure communication and assurance offered by an end-to-end encrypted connection to the end users. So if another entity has your private key, they can essentially say that they are you, or your browser will say that they are you or they belong to your entity, and they could be providing you with malicious content. In January 2021, Mimecast disclosed a certificate used by its customers to establish connection to Microsoft 365 Exchange services had been compromised, potentially impacting communications of about 10% of Mimecast users. While Mimecast did not explicitly confirm whether this was an SSL certificate, this largely appears to be the case, as suspected by some researchers. While a compromised SSL certificate is problematic, a stolen code signing certificate, for example, a compromised private key, can have far wider consequences for software security. Attackers who get their hands on the private code signing key can potentially sign their malware as an authentic software program or update being shipped by a reputable company. Although Stuxnet remains a significant example of a sophisticated attack in which attackers use stolen private keys from two prominent companies to sign their malicious code as trusted, such attacks have flourished before Stuxnet and continue to even years later. This is also why the aforementioned example of HashiCorp's GPG private key exposure in the Codecov supply chain attack is problematic. Although there's no indication yet that HashiCorp's compromised key was abused by attackers to sign malware, such an incident was a real possibility until the compromised key was revoked. So, if somebody gets your key and you find out in a very short period of time, you can revoke the key, you have to generate a new one, and then there's really no issue with them being able to sign something. But chances are there could be days, weeks in between somebody actually getting access and you finding out about it. So the possibility is there. We're next going to move to targeting developer CI and CD infrastructure. Sonatype recently observed a multifaceted software supply chain attack that not only relied on the introduction of malicious pull requests to a user's GitHub project, but also abused GitHub's own CI/CD automation infrastructure, which is called GitHub Actions, to mine cryptocurrency. GitHub Actions provides developers with a way to schedule automated CI/CD tasks for repositories hosted on GitHub. The attack consisted of attackers cloning legitimate GitHub repos that used GitHub Actions. So you look at all the open public GitHub repos and you look to see if they have actions, right? And then you just make a clone of it. So they then slightly altered the GitHub Actions script in the repository and filing a pull request for the project owner to merge this change back into their original repository. So they made slight modifications and then they asked, hey, can you pull this back into your main branch? Should a project owner casually approve the altered pull request because they don't have time to check it all, so they just said, okay, yeah, fine, a supply chain attack has succeeded. So then your code would now have malicious code inside of it. But that wasn't even the prerequisite here. So that doesn't really matter. That's secondary. That's icing on the cake, or the cherry on top. The malicious pull request contained modifications to ci.yaml, which were automatically run by GitHub Actions as soon as the pull request was filed by the attacker. So all you had to do was do a pull request, and that's it. It'll run the change that's made in the ci.yaml file. The modified code essentially abuses GitHub servers to mine cryptocurrency. Such an attack kills two birds with one stone. It tricks a developer into accepting a malicious pull request, and, should that fail, it abuses the automated CI/CD infrastructure in place for conducting malicious activities. Likewise, researchers who successfully breached United Nations domains and accessed over 100,000 United Nations staff records were able to do so mainly because they had found exposed Git folders and Git credentials files on these domains. A threat actor who obtains access to Git credentials can not only clone private Git repos, but potentially introduce malicious code upstream to trigger a supply chain attack, which would have much harsher consequences. The primary focus of those looking to prevent supply chain attacks has been on recommending secure coding practices to developers or using DevSecOps automation tools in development environments. However, securing CI and CD pipelines, for example, Jenkins servers, if you haven't watched my episode on setting up a secure Jenkins server, here is the link above. Cloud native containers and supplementary developer tooling and infrastructure has become just as important. Next up, we have using social engineering to drop malicious code. As any security professional knows, security is only as strong as its weakest link. Because the human element remains the weakest link, exploitation may come from places where it is least expected. The Linux Foundation recently banned the University of Minnesota researchers who were suggesting intentionally buggy patches that in turn introduced vulnerabilities in the Linux kernel source code. Although the instance was caught and has now been dealt with, it demonstrates a few simple facts. Developers are spread thin and may not always have the bandwidth to vet every single code commit or a proposed code change that may be buggy or outright malicious. More importantly, social engineering may come from least suspected sources, in this case seemingly credible university researchers with an EDU email address. Another recent example includes how any collaborator contributing to a GitHub project can alter a release event after it is published. Here again, the expectation of a project owner is that most contributors are submitting code and commits to their project in good faith. It takes just one collaborator to go rogue and compromise the security of the supply chain for many. Over the last year, attackers creating typo squatting and brand jacking software packages have repeatedly targeted open source developers to introduce malicious code in their upstream builds, which then propagates to many consumers. So how do you stay safe? Here are some general steps you could take. Educate users. As we saw within the phishing, you need to educate your users to spot suspicious emails and activity and contact IT if they encounter anything suspicious. We need to raise awareness with our users. We need to have them use two-form factor authentication and strong passwords and potentially password tools. Make time for regular offline backups. You need to have a backup or have multiple backups completely offline so that if your network gets infected, you are not you're not stuck paying some ransom and potentially still not getting your data back. You also want to test your backups to ensure they can be restored from reliably, and you want to do it regularly. Have a plan and review it regularly. Systems change, requirements change, and new vulnerabilities arise. You need to see who needs to make what decision when certain things happen. You also need to see what do we need to change in this plan because we now have new frameworks or new dependencies. What is our process for vetting that and making sure that we, our systems, our companies, our clients, and our software remain secure. Review your infrastructure and your hardware and software regularly. Believe it or not, there are still companies out there that still actually use bare bones metal and they use systems. They have chips on them. Those chips can be outdated. There are new viruses that attack the chip itself. You need to update and need to check your hardware, your firewalls, your switches to make sure that they're not end of life. Make sure that they have the newest firmware and that firmware is secure. You want to update your systems regularly. That goes for end devices, it goes for phones, it goes for laptops, desktops, servers, etc. You want to restrict write permissions wherever possible, especially on things like file servers. If most of your employees are only, or your team is only using the file server to download their vacation document they need to fill out, then they don't need write permission at all. Use advanced endpoint protection that can identify new malware variants and detect malicious traffic. Now, there's a number of discussions online that's been going on for years whether antivirus or anti-malware is necessary on this kind of server, like a database server, or that kind of server. For me, it goes across the board. I try to configure it so that it doesn't use too much resources from the underlying system, but there's always an antivirus or always an anti-malware system in place. If you want to check out something, you can check out my episode on installing ClamAV to secure a web server. The link will be right there above. Use email and web protection to block access to malicious websites and scan all downloads. That should be a primary rule for any end user, is that have an antivirus installed on your system that checks your mail, checks your downloads, your browser security, etc. Use at least a 2 firewall based system. You want to have an external network hardware-based firewall or software-based firewall if you're using something like AWS or Azure, as well as a local machine-based firewall. So on every system, you can install or set up a firewall. That goes also for Windows 10 or N systems. They have firewalls and software installed on it. You want to make sure that you have at least a 2 firewall-based system in your infrastructure. Restrict outgoing connections where possible. This will actually limit the ability for these types of attacks to contact their command control servers. So most of the malware and ransomware would be contacting an external server to either communicate with it and get maybe credentials or get tasks to run, or it could be passing information back to a command control center. Regardless, it needs to contact an external IP. If you restrict outgoing connections, for example, only to allow to reach your server's operating system update repos and other various traffic that's only required, then they wouldn't necessarily be able to have access to or be able to go to a specific IP address that's not within that allowed zone that you've put into your firewalls. Now, some people will say, well, they could shut off the firewall on the server itself. That is true, but when in a 2 firewall based system, the point earlier, you still have your secondary firewall, which can have overall arching rules to also block that kind of traffic. Next, you want to disconnect from networks immediately if you suspect an infection. It's better to only have one system infected and it's ripped out of the wall than to have your entire network taken over. So as soon as you notice something, rip the system out or shut the system down, disconnect it from the network. Get insurance is the final thing. Now, this is controversial considering all the talk now about the United States banning paying ransom, etc. Of all of the cases that I have studied and looked at where they have paid, there has been some help from the insurance when they have it, of course. So insurance for that absolute last-ditch requirement is something that you should look at and you should take seriously for not just for ransomware, but overall insurance for your corporation. So that's it. Thanks for watching. Don't forget to share and subscribe and smash the bell. And this time maybe say a kind word to a stranger. Okay, I'll see you guys on the next episode. Thanks for watching. Take care.